Okay, good evening, everyone. Volume down. Good evening, everyone. I hope you are glad you are here because we are. Okay, it's next Cloud Native Prague Meetup. It's number 17. It's been for a while. We are doing this for the community. And today's meetup is about FinOps. This is us. This is Zdeněk Vanya, which isn't here, unfortunately. He would prefer to be here, but he can be. And this is me. We both run Cloud Native Prague for a while. And we are running it under umbrella of Cloud Native Computing Foundation, which is a foundation that is maintaining Cloud Native projects, and it's Cloud Native Computing Foundation is under umbrella of the Linux Foundation. This is what I already said, sorry. Let's skip this. What about our community? You can follow our community page, Cloud Native Prague CZ, which will give you information about new events. We have Slack, slides with slides from the past presentations, records on YouTube. And if you want to help us, you can go to involvement.cloudnativeprague.cz and you can help us there. Those are our partners, Cloud Native Computing Foundation Bratislava, in Slovakia, Cloud Native Kubernetes Community Days that was this year in Prague, next year in Bratislava, PyCon, Prague DevOps Meetup, DevOps Days, and Go Meetup as well. And now I would like to thank our sponsor, or not sponsor, host, Heureka group that allows us to have this meetup at this place. And thanks to them, we are able to continue organizing those meetups for you. And next is Tech Meetup Ostrava. This is not sponsored, but I would like to mention them because at 1st of November, there's a meetup, no, not meetup, conference in Ostrava. I know Tech Meetup Ostrava conference. It can be a little bit confusing, so sorry about that. And if you want to have like a little bit of discount to tickets there, then you can join our Slack and in Tech Meetup channel, you can find discount codes. Okay. Okay, this is our first talk from Martin Peták, Cloud Budget on La Leash. And second talk is from Adam Hamshi, Ghost, Optimization from the perspective of a cloud architect. And if you have any questions, please use Slido. Code is CNP17. CNP17, and you can use as well the QR code to connection. Okay, I see a few phones. Okay, a few. Okay, and that's all. Let's welcome our first speaker.
Hello, everyone. My name is Martin, and I am working in Heureka Group for a little over 4 years, currently as the infrastructure team lead. Now, a little bit of history. Heureka, and I mean all of the parts of the Heureka Group, were starting on-premise. Each part had their own data centers. We were buying the servers and running everything on them. But more and more recently, we are moving more workload to the cloud. So we went from budgeting the on-premise infrastructure to need to budget the cloud one as well. And it was quite an interesting process. So I decided to create this presentation. The first part then is going to be how we are budgeting the cloud, meaning getting the number, what you expect that the cloud is going to cost in the next fiscal year, preferably per month. And then there is going to be the second part, and that is actually how to keep that budget, or even better, how to get below the budget. So let's start with the differences. How does the on-prem budgeting looks like? You need to know how many new machines you need to buy. It's capex, so you get just chunk of the money. You own the servers, nothing else. What should be the spec of the machine? Do I need something for network storage, or is it just compute? That sort of stuff. There is also the matter with old machines. Should I decommission something, or will it keep up another year? Can I count on that? And how about that network speed and the shared storage space? And what about those drives that are failing constantly? How much money I need for the spare parts? And then there is also the thing that you now can calculate everything, but in half a year when you actually need to buy it, it doesn't have to be available or the price changed quite a lot. Well, not a problem of cloud, because in cloud, you pay as you go. You always have that compute available. You don't need to care about their spec. You just set it up as you need. You don't need to decommission anything. You just pay for the compute. The compute is there. If the Google machines fail, it will just transfer you to some new server. Really, again, not need to care. The same with the storage and network. It's usually go per family of the machine or the number of CPUs. No need for spare parts. And yeah, the availability and price can differ in cloud as well, but you always have the alternatives available, and the alternatives are available immediately. You don't need to really wait for them. So that's great, right? Cloud solves it all. Before I continue, I would like to say a little bit about how our R&D work, because here in Heureka, our teams are able to work autonomously from the infrastructure point of view. We don't provide any virtual machines. We don't provide any databases. We provide a shared Kubernetes clusters. We provide tooling. We provide monitoring. But developers get their own namespace for the project. They get their own GCP project in the project, and they can just deploy anything they want. You need Cloud SQL? Sure, take it. You need to deploy another 100 pods? Sure, go ahead. So we have this very dynamic environment where we as the infra responsible for the budgeting of the cloud don't have any direct control on the workload that's actually running. So, like we said, the cloud solved all of the budgeting problems for us, but cloud is abstract, and especially its compute. Like for the developers, they didn't ever need to care about this. They just, created their application and it was running somewhere. It wasn't their problem to be responsible for how much resources it needs. The workload is unpredictable, and especially its price, because now you can use the auto scaling inside the Kubernetes, horizontal auto scaling, vertical auto scaling, and of course on top of the managed Kubernetes, you have the node auto scaling. So it's very dynamic, it's unpredictable, and also there are dependencies. I mentioned that, for example, we as the infra team are providing observability stack, metrics, logging, tracing, what you think of. But the price for these services are directly dependent on the developer services. The more pods they are running, the more they are logging, the more metrics they are having, the more expensive is the monitoring. So we can't really say, hey, monitoring is going to cost this. So how to budget all this mess? What we tried. Right now, we are using cloud more extensively for fourth year, more like fourth, because for the first year, when we decided to adopt the GCP, we tried something we called T-shirt budgeting. So we defined T-shirt sizes, we put some money on top of them, and ask developers, hey, where do you think your service is? Um, we didn't have any previous data. Developers didn't need to do anything like that ever. We were completely new to the cloud, and it was a disaster, sort of, because like you would expect, everybody over budgeted their workload. So the amount of money that ended up in the end was unreasonable. I think it was cut by either a half or a third by management, and it somehow worked out. It was a lucky guess. So second year, T-shirts didn't work out. Let's try it directly with money. There is GCP calculator. We can try. So we had some data, but we weren't able to put a price tag to a service because, again, sometimes there were 2 pods, sometimes there was 20 pods. Don't even get me started on what was running on spot instances, what was running on stable instances. That's, again, completely different. And again, everybody was over budgeting because, hey, if I put more money and don't spend it, I would get praised, right? But if it's the other way around, I would have my boss on my neck. So there was a cut applied again. And again, it wasn't really ideal. But let's go for what actually worked for us. So actually, the workload inside the GCP, if we exclude the compute, is not that hard to budget. Usually you have a Cloud SQL, you have it in some very specific tier, it's staying in that tier, so it's quite static. You may think a little bit more about traffic, number of requests, or the storage space, but it doesn't change the price much. So that's the GCP that actually was working out. But now what to do with the shared compute? The approach we have taken is that we created some kind of abstraction. We were, well, called compute unit, as you would expect. We defined the compute unit as one CPU or 4 gigabytes of RAM, depending on what's higher. And depending on the usage or the request on the Kubernetes, we are able to calculate this compute unit per namespace or per service. We also had, since this compute unit is calculated from the Kubernetes metrics, we actually had historical data we could apply this to. And so we were able to show developers how many CUs they are actually using. And based on this historical data, they can better guess what's gonna happen in the future. Developers knows their service best, how it will change or what the change might cost. What we've also came up with is something like taxing shared services, because like I said before, things like observability, Mimir, Loki, and others are heavily dependent on the usage of the developers. So the approach we are using is that we calculate all of the CUs except for the namespaces where the shared services are, then just take the price for the Kubernetes project divided by the number of CUs, and that's the price for CU. And therefore, the shared services are as a tax put there, just extra over the price. It's not always fair. I don't see any way how it actually could be fair, because you never know. You can say how many active series, for example, the service is exposing to Mimir, but then you don't know what kind of queries the developers teams are doing, which is also increasing the price. So this is how we went with it. The one question there is the networking. The observability of networking inside cloud services is just terrible. So we are doing just guesstimate. I will show you here it on the table, where when the team is budgeting their project, here we have the search. They have 3 lines they need to fill. The budget is the one for the GCP services. Since the developers have their own GCP project for the project, yes, we have billing per that project, so we know how much money that particular project is taking. Then there is the number of CUs they are expecting they will be used, and if they think they will go overboard with the network, where we say that more than 1 terabyte is let's say 1 terabyte is forgiven, and if you know about extra terabytes, you just put them there, then they put it into the table as well. And trust me, we have a really big spreadsheet with thousands of lines with this kind of data and other computations we have on top of that. But it actually something that works for us. We are able to calculate the CU price. Like I mentioned before, the GCP workloads are not that hard to estimate. And this is something that actually produce data that were accurate. We are using this system for second year now. With the first year, it was success. We will see how this year ends. So, second part of the agenda. We have the number. We know how much the cloud is going to cost us. We have it per month basis. But now we have a new set of problems. And that is that the budget shouldn't be treated as a number. And GCP is just one big number, and I am a small fish, right? So if I don't manage to keep my project, nobody notices, right? My price extra doesn't matter, right? To solve this problem, you need to create the observability. You need to be able to tell the people how many they are spending, how much they are over the budget, for example. And of course, since we know that cloud is generally expensive, if you don't take care about how you are using it, there is that as well. So, cost observability. I already talked about the compute unit. We have them based on the Kubernetes metrics. We use either requests or actual usage, depending on what's higher. And because the computation takes quite a lot of time, we are pre-computing the values using the Prometheus rules inside Mimir. And for the GCP, because we wanted to have one front end which shows you all of the price, we've created our own exporter, which is using GCP BigQuery to get the data about prices of all of the projects. Unfortunately, the GCP are providing data with 24 hours delay, so that's something that makes the user experience a little bit worse, but that's the only thing that we actually can have. I don't know how good it's going to be seen to the back, but this is how the basic Grafana dashboard for billing looks like. You can see something like hourly project costs, which is actually the GCP costs. And then at the bottom, you can see compute unit hours spent per namespace, and also some comparison for the previous time period, so you can see whether after your recent deployments the spend actually went up or down. Then there is the cost responsibility once you can see the cost. So our teams are divided between tribes, and each month we take the overall Google Cloud cost, take the data we have from our billing, and we are reinvoicing the cost for the cloud to the specific tribe based on their actual usage. Which means the bosses of the tribes see whether they are over budget or under budget. Bosses of the bosses see how the budget looks like and can put some pressure in case it's needed, which means out of the blue, people care. We also have some internal rules that teams must monitor their spend. Since it's all inside Mimir as metrics, you can actually put alert on the price if the price change, for example. But this one is really hard because, for example, now the Christmas season is coming. Heureka usually have over more than 50% of requests during this season, which means the price is going to be higher, but so is the revenue. So what to do with that? We tried some calculations like price per request, price per search, and as long as that price per search doesn't move, it's fine, because if I have more searches but price per search is the same, that's fine, that's regular traffic. But this part is really hard. Some people from Heureka also went to some other FinOps conferences, and they confirmed that the two important things for keeping the FinOps mindset is that people need to see it. And I successfully forgot the second one. Doesn't matter. Directory services are your friends. Yes, this is a little bit thanks to our IT. Since we the labeling, yes, thank you. You need to know who is spending the money. We are using GCP, so we are using Google Cloud groups for accesses, and we have these groups synced from the Microsoft Active Directory. And since it's Active Directory, we can put some extra fields in that. And since we are doing everything infra as a code, both the GCP project and the Kubernetes namespaces, we can get the data from the Active Directory and put it as a label to both namespaces and the GCP. And it also eases a lot to get the billing, per tribe and doing the reinvoices. Also, every month, we are doing something we are calling FinOps Police. It's a Grafana dashboard which is showing which project was worst, from the FinOps point of view, like who is using, who changed their actual usage of Kubernetes for the worse or for the better. We have the same table for the GCP prices. So each month, the developers can see, hey, my project is 50% worse. What happened? Is it expected? That's the most important question. Do I know about it? Did I do something that I knew caused this, or is it some other bug? And finally, we have the cost effectivity. Because cloud is expensive, and even though you budget it right, you would rather it overall cost less. Last year, we put some activity into it. We created a group of 4 FinOps drivers, and we were doing several activities during the year. The activities was about, for example, defining fincidents and doing FinOps postmortems. Like if somebody does a bug and it causes to lose some money, something costs more, it is treated as a regular production incident because it just leaks money really fast. We also defined the ownership of FinOps inside the teams and created general tips and tricks. But the important thing was to create the FinOps mindset for the developers, that they shouldn't just think about the feature or how stable the service are or how fast they are going to program it, but they should also take the money into consideration. The pinnacle of these activities was FinOps Hackathon. We had almost exactly a year ago. It was for all of the R&D for 2 days, and the FinOps was mostly and the hackathon was mostly about discovery on possible savings. We already had people who put some activity into FinOps, knew some tips and tricks, and could help. So teams had these consultants available, but it was mostly about finding possible savings. So in the next quarter, they can actually apply them. The thing is that some of the savings were actually so easy that they were done right away. These are some of our front end services, which until the FinOps hackathon were not using compression in their HTTP, nor any caching. You can see the results yourself, but basically we got to 100 of the original price. It's also sort of an estimate because not everything was already moved to the GCP, but we had the data, we had the monitoring, we had the billing, we knew how much it would cost. And there is also one other interesting thing. You can see the actual drop. This is from the GCP billing console. The blue one is the network. It's a lot. It's something like 1,000 euros per day that we actually saved. And it wasn't just for the micro frontends, because like I said previous slide, it was mostly estimation. But I also said that we are using Mimir. And Mimir in their or other way, our Kubernetes cluster is multi-zoned, and we were running Mimir on it. And we know about topology-aware routing and how you can make the Kubernetes inside GCP to keep the traffic inside one zone if possible. But Mimir doesn't care. Mimir has its own ring, and the pods are communicating directly to each other and doesn't care about anything. So this drop is, for the most part, because we put Mimir inside one zone. Again, it was a change for, I don't know, 5 lines in some Terraform or Helm. So interesting things to know your application. So how did the hackathon end it? These are actual numbers. The blue one is what was budgeted. The red one was the actual spend. So you can see we didn't hit it exactly with the budgeting process, but we were pretty close. But here we started to talk about the FinOps. Here happened the hackathon. Yes, it was December. And this is the spend since January. So in the end, even though for the whole fiscal year we were above the budget, we actually saved some money. Okay, so some latest activities we are right now doing. Through our partner Revolgi, we are trying Cast AI, which is a third-party service for right-sizing the nodes of the Kubernetes and also the workloads. This is again a screenshot from the GCP console. When we deploy the Cast AI to either dev or pre-prod environment, I'm not really sure. So you can see the saving actually is there. The Cast AI by default is doing that. It's creating custom sized nodes or nodes exactly their size is exactly for what you have inside the Kubernetes. So there is no compute that is not being used. It might be hard for the developers because at that point they need to request their resources inside pods more accurately because there is no extra traffic they can get just by not setting any limits. But it works. They also have some other features we didn't really deploy yet, but we want to, and that is right sizing of the workloads. So they can tell you how to change the request for your pod so it's more real. They can also work with scaling. Newly, they can also work with stateful set. And once the GCP applies the new feature which allows to change the request without restarting the workload, it's just a no-brainer. It also have a granular control, meaning either from web interface or Kubernetes label, you can say which workloads the cast AI should touch, shouldn't touch, put some restrictions on it, limit what's the minimum, maximum, etc. So at the bottom, it's just small screenshot from the cast AI console, which is showing some improvements. Like it wouldn't change the pod count, but according to cast, we should increase the number of memory the pods are receiving, but can severely decrease the CPU we are requesting. That's just an example. So we are continuing with our FinOps activities. And because of that, before we come to your questions, I have my own. And that is, I mentioned that, for example, the network price or the network monitoring inside GCP is really hard. So if any of you have any experience of how to tackle it, how to budget it, how to monitor it from the finance point of view, I'll be here all evening. So I'd be glad if you just came to me and we could talk about it. And there is also the matter of the FinOps alerts and alerting on FinOps incidents in general. So again, if you have any experience with that, I'd be glad to hear what you are doing with that. So that's all from my part, and I'm ready for questions. So why did we choose GCP? We get this question a lot. Before we decided to go for the cloud, we did have small projects. We were just touching it with 2 meters stake to see what happens, and we have our partner Revolgy, and we were solving, or the other way around. We are using Google Workspace. We were using it even before the GCP. Therefore, we decided to try the GCP. And once we decided that we will commit for the cloud and will be going with the platform, uh, we could have do some research and decide differently because some features are the same, some features aren't. But in the end, we decided not to waste time with it and just stick with the GCP we already had. In retrospective, I think it's a good idea because we are using the integration with Google Workspace, with our Google identities and groups a lot, and it helps us a lot. And no other provider would give it to us this easy. So no particular reason. We just had some experience previously with it. Our partner had experience with it. So yeah. Wow. Okay. So do you use unit economics? For example, measuring ratio between revenue and cost. The answer is not yet. We know about it. We talked about it. We thought about it, but it's too hard to do it, and we have a lot of other things to do, which will probably benefit the company more at this point. What about multi-cloud approach? Did you tackle this at the hackathon? Yeah. So before we committed to the cloud in general, there were a lot of workshops about whether to go for the cloud or stay on the on-prem, all cloud or on-prem hybrid mode. The multi-cloud approach wasn't even on the table. And with the decision to go for the cloud, it was also said that we don't mind vendor lock because to use cloud services effectively, you need to use them as they were designed. So that was the thought we went for the GCP. So multi-cloud wasn't on the table. And personally, with my infrastructure team lead head, I would go for multi-cloud with some backups, but I wouldn't go for the multi-cloud for the whole platform right now. Could you give us an example of incident and how you handled it? Yes, I have one in my mind. We are using the SLO generators. SLO generator is something that came from Google, and it is able to compute your service SLOs based on the metrics you are providing it, or several metrics. And it is again something we as the infrastructure team supports, and developers can use it. The thing is that developers don't know any restrictions. So there was a team which created a very, very complicated query to compute their SLOs. The query was so complicated that it cost us 500 euros a day for the monitoring project only. How we handle it, the first part was to, find out what's actually happening, why the monitoring takes so much money now. We were able to. Mimir with their tool allowed us to. So we found out, we disabled the SLO rule, we went to the team, explained them what happened, and then we decided to put limits per tenant on Mimir, just so it doesn't happen again. Do you try to compare GCP price to on-prem? That's a tough one because on the on-prem, you also need to count, let's say, the people. From my personal perspective, cloud is great for things like databases, for example, all kinds of databases. And on-prem, of course, is very cheap for the compute because you just buy the server, it's running. For example, I can say one interesting fact, and that is that the Heureka CZ uses MySQL machines, and the monthly price for virtual machines of that size that we use inside Heureka will buy us new server. The monthly price in GCP for that machine would buy us new physical server. So that's how it is in the GCP with the compute. So we weren't really comparing it, but we know that in GCP it's way easier to handle the databases instead of having it on-prem with all of the scaling, backupping, high availability, and such. On the on-prem, the compute is easier, yes, but you need to take it as a package. I am a fan of the hybrid approach. Just do what makes sense. What is currently your biggest challenge with FinOps? Since the FinOps hackathon, we weren't giving FinOps that much thought because we succeeded, as you could see on the charts. And it was mostly like, okay, let's revisit it in half a year or a year and see whether we can do something again. So, like I mentioned on the last slide, we are trying to play with the cast AI. There were some challenges for the cast AI. And right now, I would say the biggest challenge is to find time to put some energy into that as well, because right now we have a lot of other things we need to attend. So sorry, not really interesting answer for this one.
Anyone else? Okay.
Thank you.
Okay, it's time for a quick break for about 15 minutes, yeah, something like that, 20 minutes. And then we will continue with our second talk from Adam from Labyrinth Labs. And I forgot to say you, over there are toilets, over there is beer, and there are glasses. And if you take a glass, please use it all the evening. Yeah, and we have merch. We have merch, we have t-shirts and stickers, and it will be put over the somewhere there later in this evening. Enjoy. A bit of technical issues. No worries. Representative.
Počkej, ja ho musím pripojiť cez USB. Okay, are we ready? Okay. Hello, my name is Adam Hamšík, and thanks for inviting me here. Let's get to it. So I'm here for Labyrinth Labs. We are DevOps, Cloud, and Kubernetes partner. We help with our customers. Like, we are mostly a Kubernetes shop, but we also help with migrations and stuff around that. So, like, with our customers, we are very well known for like not really working around and telling them how things are. So we have a no bullshit culture here, and that's really cool and really important for us. So I'm used to be a DevOps engineer, but these days I'm going mostly to sales calls. So I really miss DevOps. So I at least go to meetups like these and talk. So I hope it's going to be useful for you. So I like to give you some overview what we are going to talk about. Like initially, we will talk about cost optimization as a topic. Like, why is it important? Like, why is it interesting for you? What to do? Then we will talk about like how we do it generally from top, like where we look, why is it hard, and where you can actually save money. And then we will go through really gore and technical details. If like we want to, we can skip that all on the top and go to the technical details. But I think it's going to be useful for you generally from the beginning. So if you fall asleep after this slide, you can definitely take something from these presentations. So you have 4 bullet points which are really important to think about when you talk about or when you try to do FinOps and cost optimization in cloud. So first one is, if you want to save money, shut everything in your cloud down. You can shut down production and you will save most. So also, like optimal cloud costs are transitive property of good software architecture. That's a very good saying, and maybe like always think about it. Like, is this a good architecture? Because that's actually going to have some costs and also some impact on your cost or architecture. And very often when you talk to cloud vendors, they tell you that it's pay as you go. It's really nice, like it's amazing, but also it's like a sword. It cuts both ways. So, like pay as you go is nice because you can shut down things, but no one really does that, you know, as you probably know. And everyone starts new servers all the time. So there's also a pay as you go cost. And also, like try avoid any shortcuts and try to do not to generate more technical debt, because that's going to have an impact later on. So why is cost optimization as a topic important for us? Like, do you know, like, do you have any metrics? Like reasoning that saying that my manager is always asking me why is it costing so much is not really an answer. But do you know how much generally companies overspend on cloud? Do you have an idea? That's one of the things. But for example, 3 of 10 companies don't really know how they spend their money on cloud. So, like here are some stats. I can provide sources from them. It's not really made up, but generally, cloud spend is really growing over the years, and like no one really knows how they are spending their money. So that's why cost optimization as a topic is really important. For example, here, like right-sizing your infrastructure can generally cut costs by 36%. That's quite a lot. Like very often, if you say that you have a 10, 20, 30,000 a month bill, that's one third of that. That's a lot. Very often when we talk to our customers, we always try to say that if you have really high costs, it's not really like a disease, it's just a symptom. Like there is some reason for that. Like maybe generally you develop software in a bad way or you make decisions in a bad way, but generally it's not a like a disease. So like why actually cloud makes sense? Because like if it's too expensive and it's always easier to run things in on premise and it's cheaper, or like why we are using cloud. Generally, from my point of view, I think it's really nice to have lower time to market, faster innovation. Those two things are really important to our clients and to us. We see a benefit from being able to deploy and be faster on the market. And also, very often when we dealt with on-premises infrastructure, like we had quite a lot of outages because someone wants to update NAS or storage and throws everything out, or switches and routers. Networking generally is pain in the ass. Yeah. And this is mostly the reason why everything doesn't work, because it's managers' fault. Okay, so how we look at the costs and where we actually try to, how we look for possibilities how to reduce it. So first thing, as my colleague before me told you, like observability is a key. Like if you want to really understand where you are spending your money, you have to have a good observability. You also, experience really helps. Knowing that compute, storage, and outbound data transfer are two main cost drivers for every single cloud vendor is really important, because that would be three of things I would look first for every customer we have. Like how optimize your cloud compute is, how optimize how storage is, and how much do you spend on data transfer. But generally, like we always try to tell them, like don't really use reserved instances until you figure out if you can shut down your servers over time. That's really important, because otherwise like you are running servers and just burn electricity and generate heat. Very often, like when we look at costs, we don't necessarily talk about like only the bill AWS send you or Google Cloud. It's also cost in people, outages, and retraining people if you have really bad infrastructure, really bad software. It's a never-ending cycle. Like you develop software, then you figure out that you have too much technical debt, and your people are burned out. You have too many operations. Everything takes time, and then the costs are rising all the time. So cost per se is not necessary only by a bill. It's also by like your time, your people, and your effort. One of the interesting things about like cost is that one of the drivers from company side, not really application side, is technical debt. Like you can very often find out that companies are really neglecting their technical debt, or they don't really care. They make a lot of shortcuts over the years, and then they have a lot of outages, or like the applications are not really efficient and they are just burning money. So we always tell our clients to make sure that they understand what's there and how to maybe improve their application, and we're there too. And also, like, don't reinvent the wheel. Like, look for others and look how to learn from others, and maybe reuse something everyone else already did. So observability is a really important metric, like where we try to figure out like how we are like spending our money. Like there are different ways how you can maybe do it, and how you like you can set up cost tags, you can set up budgets, you can do this or that, you can use some managed platform for that. But it's always good to understand that being able to see your bill and parse the invoice your AWS or Google Cloud will send you is not necessarily the only thing you have to really have to do. You also have to being able to like measure and compare that to real metrics from your application. Like maybe I can have higher latency on my application, but I will lose like 1/4 of the servers. Is that okay, or is it not? Like being able to compare the real results to your SLAs and SLOs is really important. Like sometimes you maybe can figure out a way how do you use less servers and I don't know, don't really have any outages, but have higher latency, or maybe use more asynchronous setup. So this is a funny meme where like you are a young DevOps engineer and you have your first cost optimization project. Like you look like this young Yoda, and then after it you look like a very old Yoda. So like really doing cost optimization projects are really hard and demanding. So it's really demanding on your skills. You have to think about 1,000 different options, and it takes a lot of time and effort. So it's all as it goes with issues like this. It's always good to do them often. Like don't really do it once a year because that's crazy. Do them like once in a month, once in 3 months. Make them a habit. Like this is what we do every single quarter to make sure that we understand and we know what's going on. Also, it's really nice to show those metrics you are trying to follow to your developers, because once they understand them and they see that, okay, my application will cost our company this or that much, they will try to improve that. Like it's funny how easy it becomes when you present them with real metrics and real values. Before we did that, it was really hard to explain, like guys, like can you maybe change these and don't really generate 100,000 IOPSs on our database, because it's not really import the application, and they were like, "Oh, no, that's a real rework." But when we present them with a real value, they are really costing the company every single month. Like they were very happy to do so because their managers came to them and told them, like, "Guys, this is like this is really too much." So when we talk about cost optimization, when you already in cloud, very often, like AWS will tell you, like, buy savings plan, reserve your database, and maybe use pod instances. That's basically it. And generally, for if you are a really big enterprise company, that's enough. But we always try to start here. Like you have to understand your workload. You have to look at it, understand what are the cost drivers of your workload, and maybe start there. If you refactor your application and make sure that it's mostly optimal, you can then reserve your instances, buy a savings plan, maybe use pod instances. That works very well. And you will get to a much lower bill than just buying reserved instances uh, and reserving database. And also, this is a continuous project. Like this will never end. Like this is not something you can plan into your sprint twice and then be done with that. Like you always have to do that. Like you always have in mind that, like, yeah, like what the cost is going to be. How can I improve it? Like what is the driver here, and so on. Yeah. So as I said before, like it's really good if you have a good cost visibility and you can really provide accountability to your teams and to your developers, because otherwise they don't really have connection between money and their like application and their features. Yeah, like originally when I wrote this presentation, it was for one of our customers, and we put this here just to make sure that they don't really do lift and shift migration. So if your manager comes to you and asks you to do a lift and shift, for the love of God, run away. Like put your papers in and quit the job. That's really the worst thing you can do. Like you will never be successful there. Like you can migrate the servers in the meantime. Even that project will be late, and then it will cost your company 3 times more, 10 times more, and they will be angry at you, not at them. So make sure that you don't do lift and shift. Like re-architecture your applications, make sure that they work well in cloud, and then maybe like even if it takes more time, even if it's harder, like do it the right way. There is no shortcut here. Yeah, like I think we can skip this one. And yeah, so these are the technical details. And please, if you have any questions and everything, like ask. I'm very happy to have more sort of a discussion here. So one of the things we figured out, and I already told that, is that cloud costs are transitive property of good software architecture. And very often, where you can save money is introducing extra level of indirection and cache. Like you don't necessarily have to go to database for every single transaction. You don't necessarily have to serve every single request because it's cached on the client side or on the application server side. So make sure that you utilize this as a resource for you. Like memory and CPU is quite cheap compared to traffic, compared to database usage, compared to, I don't know, Kafka. So if you can, think about it, how to utilize cache, how to make sure that you really run well. Yeah, and yeah, avoid like the high technical terms and for example, microservices. Like you don't necessarily need 100 microservices just because it's cool. Like because I don't know, Facebook and Netflix are doing it. It's not necessarily good for you. Like we have customers where they have like 6 members in a team and they're running 60 microservices. Like you can imagine that it's very funny and really good for them. Yeah, like because we are in cloud native, then look for Kubernetes. Like it's a very good way how you can actually make your workload scalable, make your workloads utilize your servers better and more. Don't be afraid of spot instances. Like very often when we talk to our clients, they generally told us, like, oh yeah, like we would like to use spot instances, but oh yeah, like they will, I don't know, die often and we will have outages. But that doesn't really happen. Like if you use Carpenter, if you set up your Kubernetes cluster well, it's going to be more or less fine. Like you will have some servers going down, but that also has some, I would call it a positive effects on your infrastructure. For example, with our clusters, we have one really big customer, and uptime on our servers is mostly around like 2 days. Like we don't really have a server which is running for more than 2 days, and that's really nice because it removes quite a lot of issues you and quite a lot of baggage you generally carry around like longer periods of time. Like sometimes things crash, sometimes your file system will fill up, or maybe your server becomes unresponsive. And by really rotating them and making sure that they die quite often, everything works fine and it's not a problem for us. This also depends on your workload, so make sure you understand that. And here is a nice example how the cluster I was talking to you about looks like. Like this is the generic traffic, and these are the events or maybe even deployment. So we generally use blue-green deployment. So we really kick that off, and after a while it goes down. And here you have around, I don't know, 300 nodes, and the lower part here is around 70. So the cluster scales up and down quite a lot over the day, and it's quite good. So very often, like one of the shortcuts developers often do is use sticky sessions. Like I would like to use the same server every single time because whatever, and be aware of that. Like that's a really bad sign for you, for your application, and for your cost. Don't do that. Like tell them that it's impossible and you cannot really do that in cloud, and make them remove that. Also be aware of single points of failure. Like it's really nice that you can add new replicas to your pods and to your deployment. If you kill your database, that's not going to work. And from our experience, it's really nice if you split your application into smaller execution parts, and not really pods which are almost the size of the node are not really good scalable units. So better use more pods and with smaller resources than other way around. Also, like we have clients where they have sort of event where before, like they start an event at, I don't know, 8 o'clock, and 1955 there is no one, like there is almost zero traffic, and 2100 there is, I don't know, 10,000 users. So Kubernetes can handle that, but it will take time to pre-scale and to add nodes and to add to make sure that the workload works. So one of the things you can really do here is not really run it all the time, but make sure that you can pre-scale your infrastructure in a way that you will be ready for the event. Black Friday is one of the things you can probably get ready this way. And also, if you do it this way, you can always scale to zero if it's needed. Like you can remove the workload. So this is one of the statistics I pulled from the sources. Around 40% of instances are at least one size bigger than they need to be, and that's really quite a lot. When we do our setup and when we tune our infrastructure, we try to utilize systems and servers to around 70 or 80% of temporary and memory utilization. That's sometimes, as you will see, not really working, but at least we try. We find out that it's always really important to load test our application. So we always, before we go to production, we always try to load test them to get better understanding of the behavior of application when it's running. And here is one simple node, which is running around 60% utilization. Yeah, like we can go higher, but I wouldn't go higher than 70 or 75. After that, it's you can really experience some weirdness there. So one of the things which is really expensive in AWS, and we are mostly using AWS, so this is a AWS related advice, is egress traffic. Even if you are using CloudFront is probably most expensive CDN you can find. It's quite expensive. So look for simple ways how you can avoid that. Like you can serve your data from Cloudflare, you can serve them from outside and not necessarily use AWS and egress traffic there. One of our clients that saved almost $20,000 per month just on egress traffic. And also, good old compression is really nice. Make sure you go and check if you are actually using it and if you are making sure your clients request the compressed files, because that could be a really nice way how to save money with bigger scale. Cross-zone traffic is one of the ways how AWS really makes money, because that's something you cannot really investigate. It's really hard to solve, and they ask for quite a lot. So every single bill has I don't know, the bigger bills are 10, 15,000 euros just on cross-zone traffic. And one of the things you can do to make sure that if you are using Kubernetes, that it works well or it's better, is maybe you can look at topology-aware routing. That's a way and feature of Kubernetes where you can provide some hints, like this pod is running here or there, in this zone or that zone, and you can actually make sure that the communication goes through the same zone if there are any endpoints or not. You can utilize VPC endpoints. That's a good feature, and will save you money. And also, you can keep workload in one zone if it's possible. One of the other things is NAT gateway. If you ever use AWS, you know that if you want to access internet from private zone or private network, you have to use NAT gateway. And AWS is introduced a thing called NAT gateway tax, that's how we call it. And it means that there is quite a hefty price attached to actual NAT gateway usage. There are different open source solutions you can deploy and make sure that you don't necessarily pay for not gateway, and it works very well. So once you have quite a lot of traffic going out of your infrastructure, make sure that you look out alternate. And you can deploy it very easily, and it's going to save you quite a lot if you want to. So it's also good to understand like what your workload looks like. Can you run ARM or Graviton CPUs? That might be a good saving point. Also, like different instance types are more or less expensive than others. One thing which is really interesting is that R7 generation, like for example for databases or elastic cache instances, it's almost 20% more expensive than R6. So if you can save money, like use R6. Like it's the performance benefit there is very negligent. And AMD instances are almost like around 10% cheaper than Intel. So if you want and you want to support AMD, like you can use that too. I talked about that already, but the spot instances are a very nice way how you can save money and don't be really tied to any compute savings plans or to any um, reserved instances. And if your workload can work with that, like I definitely suggest to you to look at them and utilize them as much as possible. We have customers who run almost 100% of their workload on spot instances, and it works very well. It works quite nice with data analytics workloads where you span quite a lot of VMs and let them run, and maybe one or two will die, but you can finish the computation later. One of the things how you can actually save money in AWS is look at the your databases. Like databases, from our experience, are quite expensive, and they are one of the more and bigger cost drivers in general bill you can find. AWS introduced a feature called IOPS Optimized Aurora Database or Aurora Instance, and very often it can save you quite a lot of money if you have heavy utilized databases. So if you have, look for that and try to use that and pay for it. They are generally more expensive than the standard one, but they are, because you don't really pay for IOPS, they can be cheaper. And here is the live example. This is the bill for cloud storage usage, cloud instance storage, instance and IOPSs, and the blue bars are like amount we pay daily for IOPS running through our database. And here is, once we switch to IOPS optimized databases, here is our bill after. So you can definitely see that the savings are quite meaningful. So quite a lot of our customers is running PHP, and over the years we more or less willingly became experts on like how to run your PHP application and make it perform better and save you money in cloud. One of the very nice examples was one of our customers' application, which was running just plain PHP FPM, and we, over the years, like we came to them like, guys, maybe we can think about like different ways how to run your application. And one of the options you have in PHP world is a thing called Swool. That's nothing really breakthrough, breathtaking, or there is no breakthrough here. it's just a persistently running application server, very similar to Spring Boot in Java. And once they ported their application to OpenSWL, we immediately saw that the application saved almost 70% of their compute of needed replicas and their compute. But because we removed quite important and hard bottleneck there, one of the things we really quickly saw is that there is still some issue, because we knew we can make the application running faster, but it was still using quite a lot of resources. And when we started to trace and look at the application and maybe use Xdebug to see what's really going on each request, we find out that the application was using sort of a configuration files which were written in XML because it was quite old. And just moving from XML to JSON gave us 20% bump there, right there. Parsing XML is really, really hard and takes a lot of CPU resources. And then we try to cache the parsed results, and we get much better. Yeah, here is the graph. Like this is the original setup. This is how it looked when we moved to SWL. This is SWL without XML parsing, and this spike here is when we started to cache the results and not really going through file system and doing IOPS every single time. So we started here around 10, and we ended up around 60 requests per pod, which is quite an improvement. And this is how it looked like on our latency. The basic latency, P99, this is the worst thing, was around 2 seconds. Like, we've been able to improve it under 1 second in general. That's a quite good improvement. And like, one of the things is that if you know your infrastructure and your application very well, you can start looking for different anomalies. Like this is something which takes quite a lot of experience, but when we were looking through this bill, we spotted one really important thing. Like, there was quite a lot of throw-zone traffic, and the bill was really high. And then we tried to figure out like what's going on. And we find out that one of our applications, which was a smaller one, was using quite a lot of network traffic to database. And because this bug was there even before we migrated to cloud, no one really noticed that. Like the application was running this way for 15 years, 10 years, and it was just how it was. And if we look at that, like the application which was not really that heavy utilized was using almost, like at the peak, it's 120 megabytes per second traffic to database. And we were trying to figure out like what's going on there. This is not really a big application anymore. There is not a lot of users. So we use our really good friends, TCP dump, Estrace, and PHP spy. Like, these are your real good friends. Like no matter how good observability you have, like you will always use these two free comrades to help you with your job. And we find out that there is actually a problem. Like developer forgot to add limit to a SQL query, and was for every single request the application received, he was executing I don't know, 50 megabyte big query into a database and gathering the results and parsing them in PHP. And like the table where he was actually doing it never really was supposed to be that big. And once we find out that what's going on, he added a limit, and that was it. Like we saved a lot of money over the years then. And this is the number of nodes we had for this application. It was quite a lot before. It was almost 40, sometimes 50. And then we became, I would probably look for the minimum number of servers here is almost as big as the maximum later after the fix. So also we not only save on the database, which could be smaller, we not only save on the network traffic, we also don't need that many servers as before. Yeah, and this one is the last, I promise. And sometimes good ideas leads to really big bills. And so we are using Thanos for our observability. And there is a like a service called Thanos Compactor. I'm not sure if you are familiar with that, but sometimes it will crash and die, and it cannot really run anymore. And no, and because Thanos works without compactor, it will not affect the service itself. We didn't really find out until 9 months later that it's not really running anymore. And we said, oh yeah, like it's definitely going to be useful. Like we should probably figure out what's wrong and start it up. And that was the good intent. Like we really meant good. But so we fixed the compactor, we started it. And then we for a month we look at it and said, oh yeah, it's working. It's definitely going to be good. And then we look at the bill, and then we spend almost 10K just compacting metrics no one really needs. So we could just drop them and be done with that, and there would be probably very little value lost there. But yeah, like we burned almost for 10K just on S3 requests and work done there. So that's all from me. Do you have any questions?
Do you have any questions? Is here. Any questions? First time, second time, third time. So, okay, I guess that's it. Thanks, Adam. And now it's time for networking. Enjoy. Take the merch, please. I don't want to take it back to office. So, thanks. Enjoy.